ગુડ મોર્નિંગ વિદ્યાર્થી મિત્રો. આજના લેક્ચરમાં આપણે પ્રેક્ટિકલ સેક્શનની વાત કરીશું. ફિઝિકલી તો પોસિબલ નથી મિત્રો, આપણા બધા માટે નવતર પ્રયોગ છે. આપણા મેથના પ્રેક્ટિકલમાં યુઝ્યુઅલી આપણે પ્રોબ્લેમ્સ સોલ્વ કરીએ છીએ, પ્રેક્ટિકલ પ્રોબ્લેમ્સ સોલ્વ કરીએ છીએ, જેમાં તમને ઇન્સ્ટ્રક્શન આપી દેવામાં આવે, તમને વે આપી દેવામાં આવે, તમે એને જાતે સોલ્વ કરો છો. In this practical section, just we are giving a way to work out the practical problems. In paper number 504, mathematical analysis, we already seen unit number 3. Some of portion of unit number 3 is already discussed. So let us see one practical today. Practical based on a matrix space. In this practical, I already listed some practical problems. All of you please see here. See, section B in a practical in our practical section B. Today we are going to discuss practical problem based on matrix space, and today is very first practical. See, as far as mathematics is concerned, either theory or practical, of course both are different thing. In theory section we are discussing the results and small problems based on that results, while in practical we are discussing larger sum practical problems. Today, see here, aim of this practical is, which of the following is our matrix space on respective set? First one, consider x is equal to r, just simple thing, distance of xy is equal to magnitude of x minus y. Second one, see, second one, distance of x is equal to, or distance of xy is equal to magnitude of x square minus y square. Third example, distance of x is equal to r, distance of xy is equal to x cube minus y cube. Fourth one, distance of xy is equal to magnitude of sin square x minus sin square y. See, these are four simple sums. Here we have to verify all the properties. If any one of them satisfy all the properties, then it is a matrix space. Now see, slightly take advanced examples. Example number 5. See here, C01. See, this one is a notation. Is a set of all continuous real valued function on the closed interval 0, 1. Set of all continuous real valued functions on closed interval 0, 1. Let's define distance function d. D from C01 cross to C01 to r. Distance of that between that two functions is magnitude of fx minus gx for all x belongs to r. Sixth one, if C star 01 is a collection of continuous function on closed interval, distance of C star 01 cross to C star 01 to r, distance of f is equal to supremum of all these things, supremum of magnitude of fx minus gx such that x belongs to 0, 1. Then we have to verify whether it is a matrix space or not. Seventh one, C star 01 be collection of integrable functions on closed interval 0, 1, and distance of fg is equal to 0 to integral 0 to 1 magnitude of fx minus gx into dx. We have to verify all the properties. See, as far as this practical is concerned, let us revise first of all definition, because we need that thing. To solve out all these sums, we need a definition of a matrix space. X is equal to non-empty set. X is non-empty set. X is not equal to 5, then X is non-empty set. Define a function dx cross x to r. This one is a sum function. if this function satisfies the following properties, then D is called a metric function on X. In order pair XD is called a metric space. First one, distance of xy greater than or equal to 0 for all xy belongs to X. This one is the first property. See in this, all these sums from 1 to 7, first property clear to all the sums. See here. Magnitude of x minus y is greater than or equal to 0, that we know. So distance of xy is greater than or equal to 0. Magnitude of any quantity, magnitude of any real number is always non-negative. So for first one, second one, third one, it is clear that all are greater than or equal to 0. That means first property is clear to 1 to 4. As well as see here also distance of between two function is just magnitude of fx minus gx for all x belongs to closed interval 0. This one is also positive and greater than or equal non-negative, means positive means is non-negative. Same way for suprema of this one is also non-negative. Here also it is non-negative, function is non-negative, function is positive, and this one is definite integration. So this one is also positive. So in your record book, everyone, you are going to write the first property for the example number 1, 2, 3, 4, 5, 6 and 7. One by one property for all examples, and then in journal you are going to separate all these examples. Separately you are going to prove all these things. See, this one is practical section, so I am not going to solve each and every problems. I am going to give just way to all of you solve how to them. Of course, for any example, one by one from 1 to 7 we are going to show all the properties. One by one. See here. Now second property for a metric space, we know that distance of xy is equal to 0 if and only if x is equal to y. Clear? Now see, for the first sum, distance of xy is equal to magnitude of x, I am leaving for you. For the second thing, see, for second example, x is equal to r and distance of xy is equal to magnitude of x square minus y square. Here we want to see that this one is 0 if and only if x is equal to y. One way it is very clear. If x is equal to y, then magnitude of x square minus y square is equal to x square minus x square, and that comes out 0. So in that case, distance of xy is equal to 0. Clear to everybody? Now converse is not true. For example, for x is equal to 2, y is equal to minus 2. This says that x is not equal to y. And what is distance of between x and y? That is equal to distance of x square minus y square, that is 4 minus 4, that comes out 0. That means x is not equal to y even though distance of xy is equal to 0. That means second property is not true. Distance of xy is equal to 0, then not necessarily x is equal to y. So for the second sum, see here, distance of xy is equal to magnitude of x square minus y square, second property is not fulfilled. One way it is true, but conversely it is not true. Whenever it is not true, then in general we need to prove it. Once again, see here, once again I would like to revise this second property. See here. In second example, x is equal to r and distance of xy is equal to x square minus y square. One way it is clear. If we take x and y are two identical points, then this magnitude is identical, x square minus x square, and that comes out 0. That means distance of xy is equal to 0 whenever x is equal to y, then distance is 0. Conversely, we have to see that thing. See, converse is not true. See here, for x is equal to 2, y is equal to minus 2, x is not equal to y, even though this distance is 0. So, if dxy is equal to 0, then x is not equal to y. That means second property is not fulfilled. Here in practical problems, of course, here we can say that xd is not a matrix space. But see, in practical exam, check all the four properties. If any function satisfies all four properties, then it is a distance function. And hence, then in that case, matrix space is there. Now, how to check the third property for that thing? X is equal to x is equal to r and distance of xy is equal to magnitude of x square minus y square. See here, in this case, very simple. Distance of xy is equal to magnitude of x square minus y square. That is equal to magnitude of x square minus y square minus x square, which is one and same thing. So that is equal to distance of yx. So distance of xy is same as distance of yx, and it is true for all xy belongs to x. So this one is symmetric property. It is satisfied for first sum as well as for second one, third, fourth, fifth, sixth, seventh, up to 7. Third property is true for all the functions. First property is also true for all. Later on we are going to see that fourth one is also true for all. Triangle inequality is also true for all these sums. So here we proved this symmetric property for second one. Similarly, you are going to prove for all remaining all the sums. Clear? See here. Now, as far as second property is concerned, somewhere it is not a matrix space. For example, magnitude of x square minus y square is not a matrix space. Of course, x cube minus y cube, in this case, it is a matrix space. Here they satisfy with all property. First one is matrix space, second one is not. Third one is matrix space, fourth one is not. See here, for the fourth one, second property. For the fourth part, x is equal to r is given to us. And distance of xy is equal to magnitude of sine square x minus sine square y is there. So, see here, if x is equal to y, then sine square x minus sine square y, that is equal to sine square x minus sine square x, and that comes out 0. On the other hand, please see here, for x is equal to 0 and x is equal to pi, y is equal to pi, we know that x is not equal to y. In that case, distance between 0 to pi is equal to magnitude of sine square 0 minus sine square pi, and that comes out 0 minus 0, and that is 0. That means distance between these 2 points x and y, distance between x and y is 0 even if x is not equal to y. So second property is not true for fourth one. It is also not true for second one. Here you are going to see that whether it is true or not for a magnitude part. See, that thing we are going to see. Now third property, up to 1 to 4 example, no problem. First, second, third and fourth property is clear. First property clear to all these 7 sums. Third property is also clear to for all the 7 sums. I would like to discuss one triangle inequality. For the third one, third example, distance of xy is equal to magnitude of x cube minus y cube. This one, this function is given. Now let us see, for all x, y, z belongs to x. distance of xy is equal to magnitude of x cube minus y cube. Can I add and subtract z cube? Yes. And use the property of modulus, which is less than or equal to x cube minus z cube plus z cube minus y cube. And this shows that distance of xz plus distance of zy. So in general, distance of xy less than or equal to distance of xz plus distance of zy. And this one is true for all xy, z belongs to x. Similarly, on same line, you can prove the fourth property, triangle inequality, for this one also. Listen me. Distance of xy is equal to magnitude of x minus y. Here we can take magnitude of x minus z plus z minus y, like as this one. Similarly for second one, third one, fourth one, fifth one, sixth one, and seventh one also it is true. So triangle inequality is true for all this one. That means in practical problems, what we are going to see, whether it is matrix space or not, that depends on a second property. Distance of xy is equal to 0 if and only if x is equal to y. Among one way, once again, it is always true. If x is equal to y, then distance of xy always 0 for any case. But whenever this x is not equal to y, even though distance of xy is 0, that comes in for example number 2, 4th. Later on we are going to discuss for the remaining. In remaining sums, in general we are going to discuss whole one sum, of course. Now see here. If we wish to see the fourth property for this integral part, let's see here. See seventh one. Similarly, you can see for the fifth one, sixth one also. See, fifth one, distance of fg is equal to magnitude of gx, fx minus gx is that. Here we can add one, take one more function, minus hx plus hx minus gx on same line. Which one less than or equal to fx minus hx plus magnitude of hx minus gx. And that is, this one is distance of fh and this one is distance of hg. So distance of fg is less than or equal to distance of fh plus distance of hg. And this one is true for all f, g, h belongs to C0, 1. On same line, we can prove the triangle inequality for the sixth one also, seventh one also. So triangle inequality is true for all the sums. Symmetricity is also true for all the sums. First property is also true for all the sums. Now we have to see for the second property. Clear? See, then one question arises, how to write in a journal? So let us prove in detail example number 4. First of all, example number 4. Example number 4. X is equal to r, distance of xy is equal to magnitude of sine square x minus sine square r. Taken any trigonometric function they can take here. See here. First one, how to write it? First property. For all xy belongs to r, it is clear that magnitude of sine square x minus sine square y is always greater than or equal to 0. And therefore, distance of xy is greater than or equal to 0. Second one, for x is equal to y, distance of xy is equal to distance of xx is equal to magnitude of sine square x minus sine square x, that is equal to magnitude of 0 is equal to 0. And therefore if x is equal to y, then distance of xy is equal to 0. On same line, if x not equal to y, even though distance of xy is 0, see here, for converse, for x is equal to 0 and x is equal to pi, you can take here any value. Any value means any value from zeros of sine function. Distance of x is equal to 0, y is equal to y. Then distance of xy is equal to distance of 0 to pi. That comes magnitude of sine square 0 minus sine square pi. And we know that both are 0 minus 0, that comes out 0. So distance of xy is 0. That means if x is not equal to y, distance of, that means distance of xy is 0 even if x is not equal to y. So we can say that distance of xy equal to 0 if and only if x is equal to y is not true. This second property is not true. So it is not a matrix space. But see here, we are going to prove third property. See here, third one. Third property, distance of xy is equal to magnitude of sine square x minus sine square y, and that is equal to, we can write magnitude of sine square y minus sine square x also. This says that distance of yx. So distance of xy is equal to distance of yx, and it is true for all xy belongs to x. So third property is proved. Fourth one, for all xy belongs to x. For all xyz belongs to x, distance of xy is equal to magnitude of sine square x minus sine square y. That is equal to magnitude of sine square x minus sine square z plus sine square z minus sine square y. Add and subtract. Now use the property of magnitude. This one is less than or equal to magnitude of sine square x minus sine square z plus magnitude of sine square z minus sine square y. And this one is our distance between x and z as per definition, and this one is distance between z and y, zy. So distance of xy less than or equal to distance of xz plus distance of zy, and it is true for all x, y, z belongs to x. So in this case xd is matrix space, not matrix space. Why? Because second property is not true. That means verify, in a practical problems we need to verify all the properties. If any one of them property is not true, then it is not a matrix space, otherwise it is a matrix space.